Hello students, welcome. Previously in Kcse preparation tips, Kcse chemistry paper 1, we were dealing with the part 4 and we were dealing with the Kcse 2008. So today part 4, we are going to do Kcse 2009. So question 1, it is from Kcse 209, chemistry paper 1, question number 2. The question is, we are told, hardness of water may be removed by either boiling or addition of chemicals. So part A of the question, we are told write a question to show how boiling removes hardness of water. Remember, learners, boiling removes only temporary hardness, and the chemicals or the compounds that cause temporary hardness were calcium hydrogen carbonate and magnesium hydrogen carbonate. So if that water contains calcium hydrogen carbonate, when it is boiled or when it is heated, it forms calcium carbonate, which is a precipitate, plus water, which is a liquid, plus carbon dioxide. That's the equation to show how boiling removes temporary hardness. Or in case that water contains magnesium hydrogen carbonate, boiling or heating it gives us magnesium carbonate, which is a precipitate, plus water, liquid, plus carbon dioxide, which is a gas. Remember in form 2, we said all carbonates are insoluble except group 1 carbonates and also ammonium carbonate. So that means calcium carbonate or magnesium carbonate is insoluble carbonate, so it's a precipitate. So, but B of the question, we are told name 2 chemicals that can be used to remove hardness of water. So we have one, we can talk about sodium carbonate. Number 2, we can talk about calcium hydroxide. Number 3, we can talk about ammonium hydroxide. Ammonium hydroxide solution. Or which we can say aqueous ammonia. Aqueous ammonia. So here you are asked only 2 chemicals, but we have given around 3. So you only state 2 chemicals that can be used to remove hardness of water. So question 2, it is in Kcse 2009, chemistry paper 1, and it was question number 16. So to read the question, we are told the solubility curve for potassium nitrate is as shown below. This is the solubility curve given. Before we go to the questions, let's check first of all the scale that they have used. The scale they have used in x-axis is 1 centimeter square to represent 10 degrees Celsius. To represent 10 degrees Celsius. So here we have 10, 20, here we have 30, here we have 40, here we have 50, 60, 70, 80, 90, then we're having 100 there. Then to see the scale that they have used in y-axis, it is 1 centimeter square to represent 20 gram by 100 gram of water. That's the scale that they have used. Okay, so let's go to the question. We are told determine the solubility of potassium nitrate at 50 degrees Celsius. So at 50 degrees Celsius, it is here because this is 40, this is 50, this is 60. So let us see now the curve. The curve for potassium nitrate is here. So where is it cutting now? That 50, a temperature of 50. It is here. If you check here, it is in between this line and that line of 80. So using the scale, the way we have seen on the y-axis, we said 1 centimeter square represents 20 gram by 100 gram of water. But what about this small square box, 1 centimeter square of a small box represents 4 gram by 100 gram of water. So that means when here is 60, we are going to have 64, we are having 68, we are having 72, we are having 76, then we are having 80. So it's in between 76 and 80. So in between 76 and 80, we have 78. So we're having 78. So what is the unit for that solubility? We have it here, gram by 100 gram of water. So we have 78 gram by 100 gram of water. That will be the solubility of potassium nitrate at 50 degrees Celsius. Okay, but B of the question, we are told determine the molar concentration of saturated solution, saturated potassium nitrate at 50 degrees Celsius. That's the question that we are asked. So, what is the mass of potassium nitrate at 50 degrees Celsius? It's 78. What solvent has it been dissolved? 100 gram of water. So we can say 78 gram of potassium nitrate has been dissolved in 100 gram of water, or 100 centimeter cube. So we say, what about 1000 centimeter cube? We want to make our mass in grams per liter, or our concentration in gram per liter. So here we are going to have 78 times 1000 divided by 100. So here we are going to get 780 grams per liter. Okay, so we want to use the formula for calculating concentration or molarity in concentration in gram per liter over the RFM. We want to use that formula. Molarity equal to concentration in gram per liter over the RFM. So I have to get RFM. So how are we going to get RFM of potassium nitrate? So potassium is 439, then nitrogen is 14, plus 16 times 3 for oxygen. Here we are going to get 101 as the RFM of potassium nitrate. So writing molar concentration or molarity, I want to write the formula, will be equal to concentration in grams per liter over the RFM. So in our case, our concentration in gram per liter is 780 grams per liter divided by the RFM. The RFM here is 101. So in doing so, we are going to get 7.723 mole, or that's our molarity. So check the question. We are told determine the molar concentration of saturated potassium nitrate at 50 degrees Celsius. It is 7.723. So next, we are going to go to question 3. And in question 3, we are having use Kcse 2009, question number 23 in chemistry paper 1. Okay, use the flow chart below to answer the questions that follow. So the flow chart that we are having here, we are having aqueous iron 2 sulfate solution. Then in step 1, we have added there hydrogen peroxide. Thereafter, we are going to get solution B. Then that solution B, we add the aqueous ammonia in step 2. Then we are going to get solid Q. In step 3, we are going to heat. We are going to get iron 3 oxide, and also we are having substance H. So before we go to the question, let's try to analyze the flow chart. Then we just answer the questions that they are going to ask us. So here we are having aqueous iron 2 sulfate. That means hydrogen peroxide is an oxidizing agent. So it oxidizes iron 2 ions into iron 3 ions. So that means substance B will be iron 3 sulfate solution. It will be iron 3 sulfate solution. So if we add aqueous ammonia to iron 3 sulfate solution, that means we are going to get ammonium sulfate plus iron 3 hydroxide. So that means this solid Q will be iron iron 3 hydroxide. It will be iron 3 hydroxide, which is a precipitate or which is a solid. So if you hit iron 3 hydroxide, that means we are going to get iron 3 oxide plus water. So that means our substance H will be water. Okay, let's go to the questions now. We are told what observation will be made in step 1. Step 1 is where we are going to have aqueous iron 2 sulfate being converted to aqueous iron 3 sulfate. So the observation there is Bell green solution of iron 2 sulfate turns to yellow. Turns to yellow iron 3 ions. So the observation will be Bell green solution turns to yellow. But B, we are told name another substance that could be used in step 2. In step 2, they have added aqueous ammonia. So instead, we can use another substance like sodium hydroxide. Sodium hydroxide. So if you don't want to use sodium hydroxide, you can as well use potassium hydroxide. You can use potassium hydroxide. Remember, here, when solutions or ions of iron 3 ions are added to aqueous ammonia, we are going to see a precipitate, a brown precipitate. So just like that, when sodium hydroxide is added to solution containing iron 3 ions, we are going to get still that brown precipitate, which is insoluble in excess. Okay, next. But C, we are told give the name of substance H. We have said already that one is water, and we know the reason why we are getting water. Because we know when metal hydroxides are heated, we are going to get metal oxide and also water. So that means here we are having iron 3 hydroxide. When it is heated, we get solid iron 3 oxide and also water. So thereafter, we are going to go to the next question. And the next question, question number 4, we are getting from Kcse 2009 chemistry paper 1, and it was in question number 25. Okay, to read the question, we are told for each of the following reactions, state the observation. State the observation and write the formula of the compound responsible for the observation. Part A of the question, we are told bromine water is added to aqueous potassium iodide. So the observation that we are going to get there will be colorless solution. Colorless solution becomes brown or becomes black. Okay, why is it like that? Because here we are using bromine water and we are having that aqueous potassium iodide. So that means bromine oxidizes iodide ions to brown colored iodine in solution, while itself gets reduced to bromide ions which are colorless. Bromide ions which are colorless, hence does not contribute to the final color of the solution. Does not contribute to the final color of the solution. So what about the formula? Because we have to write the formula. So the formula that is responsible for this observation will be iodine. Okay, next, but B, we are told excess aqueous ammonia is added to copper 2 hydroxide. So if we take copper 2 hydroxide, then we add excess ammonia, that means complex ion will be formed. That is tetraamine copper 2 ions. So the color of copper 2 hydroxide is a blue precipitate. So that means a blue precipitate dissolves in excess ammonia to form a deep blue solution. So that's the observation. That means initially we had a blue precipitate, that's copper 2 hydroxides, we're having a blue precipitate initially. But now, when it dissolves in excess ammonia, we are going to get deep blue solution. So that's the observation. So what is the formula for the compound responsible for this observation? Will be that tetraamine copper 2 ions. So it will be written, the formula should be written like this. So this will be the formula for the compound responsible for this observation. That's the end of our lesson.